Alright, today we're going to go over the 2.7 homework, part 2. This will be video 1. We're going to start at 22 to 40, even, 50, 52, 53 through 55, 56, and 60. I don't know if this will all fit in one video. We're going to find out. Alright, so that's it. Alright, 22 through 30, we're going to work backwards. So they're going to give us solutions, and I'm going to make an equation show up. So the first thing I have to do is I have to see how many zeros I have. In this one I have 3 solutions. Now, I'm going to put in the x. Remember, whenever you put it in parentheses, or you're going to make all those equal to x. Those are your solutions. If I were to solve a problem, I would get x is equal to negative 5, x is equal to negative 1, x is equal to 2. Now, I'm going to put the parentheses back in. And that means when I work backwards, I just change the sign. Because remember, if we would have solved x plus 5 set equal to 0, it would give us this x is equal to negative 5. I have negative 1 here, so I have x plus 1 here. I have positive 2 there, so I have x minus 2. And technically, the whole thing is equal to 0. This, in our last problem, we went from this step to this step. Now we're going backwards. All right. Now we have to multiply. So I have to pick 2. And I'm going to multiply those two together. So I'm going to pick 2 to multiply. I get x squared, doing the first, plus x, do the inside, plus 5x, plus 5. And I didn't do anything with x minus 2, so it just stays x minus 2. Combine those two, x and 5x together becomes 6x. Right? So I have x squared plus 6x plus 5, all times x minus 2. Now I'm going to take this x, it's going to go to everything. So x going to everything gives me x cubed. X times 6x is plus 6x squared, and x times 5 is plus 5x. Now, I'm going to take negative 2. It's going to go to everything. Negative 2 goes to x squared, gives me minus 2x squared. Notice I'm lining everything up. Minus 2 goes to 6x, gives me minus 12x. Minus 2 goes to 5, gives me minus 10. I combine my like terms. My final answer is going to be x cubed plus 4x squared minus 7x minus 10. Remember, technically the whole thing's equal to 0. That makes it an equation. So I set it equal to 0. To make an equation. Alright, and that's my final answer right there. Alright, so 24, I have my solution, so I'm going to make x show up. So this is going to turn into x is equal to 2, x is equal to negative I, x is equal to I. Since I have I have to have conjugates. But I and negative I are conjugates, so I don't have to do any work. I don't have to make up any. Alright, these two are conjugates, so I don't have to do any more work. Alright, I'm going to put my parentheses back in. So this line is going to turn into x minus 2, x plus I, because remember I changed the sign, and x minus I, because I changed the sign. Alright. When I multiply the conjugates first. So I multiply these two first. I get x times x is x squared. X times negative I is minus xi plus xi, and then minus I squared. Xi and negative xi cancel. I squared, remember, I squared equals negative 1. So the opposite of negative 1 is plus 1. So this turns into x squared plus 1. I didn't do anything with x minus 2. Now I just FOIL again. I'm just going to distribute again. So x is going to go to x squared and 1. So I get x cubed plus x. Then negative 2 is going to go to x squared and 1. So I get minus 2x squared minus 2. And just to finish that out, I'm going to make that equal to 0. Or sometimes you'll see it written this way, f of x equals x cubed. And I'm going to put it in standard form. So it's going to say minus 2x squared plus x minus 2. And that's it. Alright, so 26, I'm going to make my x's show up. So this goes to x is equal to negative 1, x is equal to 2, x is equal to negative 3i. Since negative 3i shows up, I must have the conjugate. So I make x is equal to positive 3i because those two right there are conjugates. So whenever an I or a radical shows up, they show up in pairs. So even if they don't write two of them, you have to make both of them show up. Now I make my parentheses show up. X plus 1, x minus 2, x plus 3i, x minus 3i. I'm going to FOIL the first two and the second two, because remember I have to multiply conjugates first. So I go x goes to x gives me x squared, x goes to minus 3i gives me minus 3i times x. Then I have plus 3i times x. And then 3i goes to negative 3i gives me minus 9i squared. Those in the middle cancel. This turns into x squared. And remember, I squared is negative 1. So it becomes plus 9. This turns into, I FOIL it, x squared minus 2x plus x minus 2. It becomes x squared minus x minus 2. Now, x squared is going to go to everything. So I get x to the 4th minus x cubed minus 2x squared. Now 9 is going to go to everything. So I get 9x squared. Notice I line it up with the x squared. 9 times minus x is minus 9x. 9 times negative 2 is minus 18. I lined everything up. So my final answer is x to the 4th minus x cubed plus 7x squared minus 9x minus 18. I can either set it equal to 0 or I could put f of x in front. Doesn't really matter which one. I knew this was going to be x to the 4th since I had 4 solutions in the beginning. So that's one way to check your work. Alright, there was 1, there was 2, there was 3 they gave me, and the conjugate showed up the 4th one. So that's it for 26. Alright, 28, I have 3 solutions, 4, radical 5, negative radical 5 that are given. Since radical 5 shows up, I must have the conjugate. And luckily, both of those show up already, so I do not have to make up another solution because it's already there. They're conjugates already. So I don't even have to add anything. So I say x is equal to 4, x is equal to radical 5, x is equal to negative radical 5. Now, we're going to work backwards, so I say x minus 4. I change my sign, x minus radical 5, x plus radical 5. I multiply my conjugates together first. So I pick these two to start. X goes to x, that's x squared. X goes to radical 5. Remember, x is outside. Radical 5 is inside, so they can't be combined, so it's just x radical 5. Radical 5 goes to x, so it's minus x radical 5. And radical 5 goes to radical 5. Remember, radical 5 negative times radical 5 equals, you multiply these two together, radical 25, the square root of 25 is 5, so the radical just disappears. These two cancel, so this these last two parentheses turn into x squared minus 5. Didn't do anything with x minus 4, so it just stays there, and I FOIL again. X goes to x squared, gives me x cubed. X goes to minus 5, gives me minus 5x. Inside is minus 4x squared, and then plus 20. So my final answer, just to put it, you could set it equal to 0, or you could say f of x equals x cubed minus 4x squared minus 5x plus 20. And that's your final answer. Alrighty, 30, I have negative 2, negative 1, 2, 3, and radical 11 all as my solutions. So since I have radical 11, I must have the conjugate negative radical 11 also. Since that's not written, I have to add that when I make my x's. So I have x equal to negative 2, x equals negative 1, x equals 2, x equals 3, x equals radical 11, and x equals negative radical 11. So now I make my parentheses. X plus 2, x minus 2. I'm going to put this one here. So I have those two next to each other. X minus plus 1, x minus 3, x minus radical 11, x plus radical 11. Now I'm going to go through and I'm going to pick my conjugates first. So I pick my conjugates first. And I pick these two. Alright. I FOIL it. X goes to x. That's x squared. The insides cancel. And then radical 11 times radical 11 is the opposite of radical 121. The square root of 121 is just 11. So it's x squared minus 11. That stays the way it is. Do these two next. I'm going to get x squared. The insides cancel because they're opposite signs. Minus 4. And then I'm going to do these two. So I'm just doing two at a time. I'm just multiplying two at a time. I get x squared minus 2x minus 3. I'm going to change my order up a little bit. I'm going to make these two first because they're going to both be pretty easy. So I get x squared minus 4, x squared minus 11, and then x squared minus 2x minus 3. I do this because it's easier to multiply two things times two things than two things times three things. So I'm just going to do this first. So x squared goes to everything. X squared goes to x squared, gives me x to the 4th. The inside becomes minus 4x minus 15x squared plus 44. So now I have 3 thenes times 3 thenes, and I'm going to continue this on to the next page. So this is going to continue on the next page. Alright, so from the previous page, remember, I'm going to just continue this. X to the 4th goes to everything. Gives me x to the 4th times x squared is x to the 6th. X to the 4th times minus 2x is minus 2x to the 5th. X to the 4th times minus 3 is minus 3x to the 4th. Now 15x squared is going to go to everything. So negative 15x squared is going to go to x squared, negative 2x, and negative 3. So negative 15 times x squared is minus 15x to the 4th. Negative 15x squared times minus 2x is plus 30x cubed. Negative 15 times minus 3 is plus 45x squared. Now, 44 is going to go to everything. So 44 times x squared is 44x squared. 44 times minus 2 is minus 88x. 44 times negative 3 is minus 132. Combine up all my like terms. Notice I lined everything up because it does all the work for me, so my final answer is f of x equals x to the 6th There is nothing to go down with. Negative 2x to the fifth, so it's negative 2x to the fifth, minus 18x to the fourth, plus 30x cubed, plus 99x squared, minus 88x minus 132. So that one's really long and drawn out. Oh, and that should be an 89, not a 99. Sorry. So let's fix that. So the only mistake is that should have been 89. I went crazy there for a second. And once again, I knew this was x to the 6th because I had 6 solutions in the beginning. If I go back and look at my last page, I had solution 1, solution 2, solution 3, solution 4, solution 5, solution 6. That's why I knew it was going to be x to the 6th at the end. That's why I know I'm at least on the right track. And that's it. 32. If you look at their problem, they have only one set with I, so they forgot the conjugate of 1 plus I. All they have is 2 and 1 plus I, and they forgot 1 minus I. That's what they forgot. They forgot that. So you make your x is equal to 2, x is equal to 1 plus I, x is equal to 1 minus I. I need conjugates. That's why that's there. So this and this are conjugates, so they're both there. Remember, I do that. I change both the signs when I make it in parentheses. So I make that minus 1, minus I, x minus 1 plus I, and then I didn't do anything with it. I make it x minus 2. So I changed both signs. I multiply that first because they're conjugates. So multiply this first. The book, like I said, the book shows a shortcut. They say this is a, so it's x minus 1 squared. And then it's minus I squared. That's the shortcut. X minus 1 squared is x squared minus 2x plus 1. Minus 1 squared is plus 1. So this becomes x minus 2 times x squared minus 2x plus 2. X is going to go to everything. Give me x cubed minus 2x squared plus 2x. And then negative 2 is going to go to everything. Gives me minus 2x squared plus 4x minus 4. So my final answer is x cubed minus 4x squared plus 6x plus 4. And we can say that's equal to 0, or you could have said f of x equals the whole thing. And that's it. Except that should be plus negative 4. So make that minus 4 at the end. I don't know, I just went crazy here. So that should be minus 4. And that's it. Alright, 34 through 40 are actually be pretty simple. We didn't talk about it in class yesterday. We're going to talk about it today. The first thing you have to do is to find the positive real zeros. You just count the sign changes in everything you see. Because 0 is 0 does not have a sign, you don't need placeholders. So that's one thing that some of us are going to mess up with. So since 0 does not have a sign, you don't need placeholders. So you're going to just count your sign changes. That gives you the positive real zeros. Now, to find the negative one, you plug in negative x for everything. You simplify. And then you count your sign changes again. That gives you the negative ones. Then finally, to find your imaginary zeros, you take your degree, which is the highest exponent, that's the total zeros. You subtract those positive zeros and those negative zeros, and that gives you whatever's left over. So you're just going to have a list on 34 through 40 of how many zeros you have. I don't need you to find the zeros, I'm just telling you to tell me how many there are. Alright, so 34, we have f of x equals x to the fourth minus x squared minus 6. So for positive, I don't change anything. I just write it exactly the same. I say x to the fourth minus x squared minus 6. This is positive, so I went from positive to negative. That's 1. Negative to negative, that's none. So I have one sign change, meaning I have one positive 0. Now negative, you have to plug in a negative x wherever you see an x. So I have to plug in negative x for x. So I say negative x, remember it's in parentheses, to the fourth, minus negative x squared minus 6. Remember, a negative to the fourth power is a positive, so it just stays x to the fourth. A negative to the second power stays positive, so it's minus x squared minus 6. Now I count my sign changes. Remember, this is plus, so that's 1. Negative to negative is 0, so this one's going to have 1 negative 0. So I have 1 positive 0, 1 negative 0. Because the degree is 4, I subtract my positive 0. So I say 4 minus 1. Then I subtract my negative minus 1. That's going to give me 2 imaginary. And that's it. So I have 1 positive, 1 negative, and 2 imaginary. That's all we do for this problem. Alright, so 22, or 36, we're going to do the same exact thing. I say f of x, so the positive, I don't change anything. So I have x cubed minus 4x squared plus 8x plus 7. Positive to a negative, that's 1. Negative to a positive, that's another 1. Positive with positive, that's not 1. So I have 2 positive solutions, or 2 positive zeros. Alright, that's step 1. To find the negative, I put in negative x, 4x, and then I got to simplify. So I put negative x in here for the cubed, minus 4 negative x squared plus 8 times negative x plus 7. Now notice, because I have odd exponents, because I have these odd exponents, things will actually change. So this negative x cubed becomes minus x cubed. The negative x squared doesn't change, so it says minus 4, then it stays x squared. Negative x changes that changes, so it becomes minus 8x plus 7. So we have negative to a negative, no sign change. Negative to a negative, no sign change. Negative to a positive, 1 sign change. So I have 1 negative 0. Now my degree is 3. I subtract my positive, so I get 3 minus 2, and then I subtract my negative, so minus 1 is 0 imaginary. And that's it for 36. 38 is exactly the same. Alright, 38, exact same concept, so to find the positive, I discount x to the fifth minus 3x cubed plus 8x minus 10. Remember, placeholders don't matter. So I say positive to a negative, that's 1. Negative to a positive, that's another 1. Positive to negative, that's another 1. So I have 3 positive zeros. Now I do the negative. Remember, the negative says that you have to plug in negative x for everything you see. And the key is you have to remember odd exponents, change sign, even don't. So negative x to the fifth turns to minus x to the fifth. minus x cubed, that changes that to plus 3x cubed. Plus 8 turns it to minus x, or 8x, minus 10. So negative to a positive, that's 1. Positive to a negative, that's another one. Negative to a negative, that doesn't change. So I have 2 negative zeros. So finally, I take my degree, 5, and I subtract my positive, which is 3, and then I subtract my negatives, which is 2, and together, that's 0, that's my imaginary. And that's it for 38. All right, number 40, exact same concept. No change. There's a change. There's a change. No change. No change. There's a change. So I have 3 positive zeros. Since my degree is 6, I subtract my positive zeros. That means I'm going to have 3 imaginary zeros. And that's it for 40. All right, 50, there's 2 zeros of this function, x cubed minus 6x squared minus 16x plus 96. 2 of them are 4 and negative 4. Explain why the third has to be a real number. So if you're listening to this, I'm not going to give you guys the answer because I really like this question. It's a really good question. If you could explain it to me, I'm going to give you a bonus point. If you're lost on this, think about complex conjugates and irrational conjugates and what we know about them. When they show up, what do we know? So that's going to help you with that one. All right, so 52 is multiple choice. So I'm going to just talking about the classifying the zeros again. So I'm going to do my positive. X, that's a sign change. Positive to negative. Negative to positive is another sign change. Positive, positive, not a sign change. Positive, negative is a sign change. So I got 3 positives. Now I put in negative x for everything to get my negative. So I have negative x to the 5th minus 4 times negative x to the 3rd plus 6 times negative x squared plus 12 times negative x minus 6. It becomes minus x to the 5th plus 4x cubed plus 6x squared minus 12x minus 6. Negative to positive, that's 1. Positive to positive, nope. Positive to negative, 1. Negative to negative, none. So I have 2 negatives. Zeros. Well, the degree is 5, so if I subtract the positive, 3, and I subtract the negative, 2, I'm left with 0 imaginary. And you actually have to look at the book to tell me which number this is. Remember, this is multiple choice. All right, for 53 through 55, it's actually really easy. You just look and see the degree means, that's how many solutions there are, and then you just see where they cross. Whatever they don't cross is what's left over. So this crosses once on the negative, that's negative. That's negative. So that means I have 2 negative solutions. That's positive. So I have 1 positive. And if there's 3 total, that means I have no imaginary. I have degree 4. I have 1 negative. I have 1 positive. That means if I have 2 total, I have to have 2 imaginary. 55. It only crosses 1 time on the negative. There's no positive, which means I have to have 4 imaginary. And that's it for this. 56 and 60 we'll talk about in class. That's it.